Okay, minasan, konnichiwa, Zamurai Engineer desu. In this section, we'll live stream the discussion on columns. How do we design, how do we analyze columns? This is an introductory chapter. So please check the sound. So then let's proceed. Check the sound. So I have to check it myself. Let me check it. Okay, good. So it is working properly. So therefore, let us continue. So column is another structural element that we have to use to construct a building or a bridge, another structure, and this can be an application that would use reinforced concrete. So there are different types of columns. So let us talk about different types of columns. So we have what? Short compression blocks or pedestal. So that is the number one. Number two is short reinforced concrete columns. And number three is long or slender reinforced concrete column. So there are three. So pedestal, short column, and long column. So those are the three types. So let us proceed with the column discussion. So we are very familiar with this. This is what? Compression type of structure. We already discussed this on steel design. Similar concept. Okay, similar concept. We have the moment P times caps delta. Okay, so P times caps delta. So again, there are types of column according to height. That is pedestal, short, and long. So there are three. But there are two types with respect to the configuration of the reinforcement and the steel. Okay? So we have what we call tied column or spiral column. So there are two types. As you can see here, we have the tied column here and we have the spiral column here. So it doesn't matter if the column is circular or rectangle, but the reinforcement must be like this. So this is the reinforcement. So it is spiral column. So the reinforcement is vertical, of course, the main, but we have the spiral steel secondary reinforcement. Okay. So similarly, for the tied column, we have the main reinforcement and we have the what? The ties or the this horizontal reinforcement. We have the vertical or longitudinal and we have this transverse. Okay. Like this, that look like this. This is the what? The ties. Okay. Then we also have composite column. Okay, so as shown in the other composite. So composite here, composite type, meaning we have this tight column steel reinforcement. We have also the W section. We have W section here side. We have the concrete part and we have the structural pipe, and therefore this and this one are what we call composite column. They are not reinforced, they are composite column. Okay, so axial load, capacity of columns, how to compute it? For axial load, very simple. This is from the mechanics subject and theory of structure. We have this formula. Okay? Okay. So this is the concrete part and this is the steel part. Okay, so the reinforcement part. So the reinforcement resistance and the concrete resistance total, that is the nominal force. Okay. Failure of tight and spiral columns. We have, of course, different factors. Okay. So I think for tight column, phi is 0.65, and for spiral column, phi is equal to 0.75. Okay. So we have different formulas for shell. So shell strength. Okay. So we have, where is the diagram for shell strength and spiral strength? So we have two of these. This one. So we have the diameter of the concrete. Okay. So this is the spiral type over. Notice the spiral steel is outside the longitudinal bars. Okay. Pitch is equal to S. So that is the spiral pitch distance. So H is the diameter, DC is the concrete cover, no? Concrete cover. So diameter, so we have columns and hammer cup forms for these applications. Hammer cup forms columns. Okay. So columns are very important. Okay. Code requirements. So there are several requirements. Some of the most important are the following. Number one. Okay. So the reinforcement may not be less than 1%. Right? 1%. It is felt that if the amount of steel is less than 1%, there is a distinct possibility of a sudden non-ductile failure, as might occur in a plain concrete column. So negligible steel, that's why it is now non-ductile. 1% minimum steel value will also lessen creep and shrinkage and provide some bending strength. Okay, that is true. Actually, the code does permit the use of less than 1% steel if the column has been made larger than is necessary to carry the loads because of architectural or other reasons. In other words, a column can be designed with 1% longitudinal steel to support the factored load, and then more concrete can be added with no increase in reinforcing and no increase in calculated load carrying capacity. In actual practice, the steel percentage for such structure is kept on absolute minimum of, take note, absolute minimum So 0.5%. So absolute minimum. Minimum is 1%, but if you're going to use even lower than that, so 0.5%. Then number 2, okay, maximum percent of steel may not be greater than. So minimum, maximum given. Maximum is 8%. Okay. This maximum value is given to prevent too much crowding of bars. Okay. Practically, it is rather difficult to fit more than 4% or 5%. Take note of these values. You have to memorize this. 1%, 8%, 4%, 5%. Still into the pores and still get the concrete down into the pores and around the bars. When the percentage of steel is high, the chances of it being honeycomb in the concrete is decidedly increased. Honeycomb are those, but I will show you the honeycomb. So I will get some example of honeycomb. Honeycomb. Okay. This and I show you this chrome. Show you the chrome. Okay, so you have this honeycomb. This is what we mean by honeycomb. Okay, so honeycomb here, there, those are the honeycomb. Okay, so and here, there, honeycomb, very bad honeycomb. Column is a column, but because of honeycomb, there is no strength in this column. This is a failure. This is a failure. Okay, failure of construction. So these are the type of honeycomb. Okay, these are honeycombs. So to prevent that honeycomb, okay, so what will you do? So less amount of steel, okay, or vibrator. You have to have the special equipment, okay, called vibrator in order to compact the wet cement, the wet concrete into the between the steel, around the steel bars. Okay. So usually the percentage of reinforcement should not exceed 4%. That is the reason why when the bars are to be lap spliced, it is to be recommended to remember that if the percentage of steel is very high, the bars may be bundled. Okay, you can bundle the bars actually. Then number 3, the minimum number of longitudinal bars permissible for compression members. Minimum, okay, it must be distributed around the that's why the minimum 4 bars within rectangular or circular ties, 3-4 bars within triangular shape ties, and 6-4 bars enclosed within spiral. So 6 for spirals, 4 rectangular, 4, and 3 for triangular. Okay, so those are the minimum. Number 4, the code does not directly provide the minimum column cross-sectional area, but it is obvious that minimum widths or diameters of about 8 inch to 10 are necessary to provide the necessary cover outside the ties of the spirals. Okay? 8 inch to 10 inch. Okay? There is no minimum column cross-sectional area, but we have what? 10 to 8. So 8 inch is about 200. 10 is 250. Okay? So as small as that, a small column like that, necessary. Okay? To use as little rentable floor area as possible if you have very big columns. So small columns are frequently desirable. In fact, thin columns may often be enclosed or hidden in walls. Okay? So number 5, when tied columns are used, the ties shall not be less than number 3. Number 3. So ties number 3, that is 9.5 mm. Provided that the longitudinal bars are number 10 or smaller. So the ties can be as small as number 3. The minimum size is number 4 for longitudinal bars. So number 4 is actually 12 mm. Okay. So and for deformed wire or welded wire fabric with an equivalent area may also be used. In SI units, ties should not be less than 10 for longitudinal bars, 32 or smaller, and 13 for larger longitudinal bars. Okay? So, then number 6, the code states that spirals may not have diameters less than spirals 3/8 inch. Okay, and that 3/8 inch. Okay, 3/8 inch diameter. That the clear spacing between them may not be less than 1 inch or greater than 3 inch. Should these places be necessary in spiral, they are to be provided by welding or by lapping deformed uncoated spiral bars or wires. So that is the minimum dimension, but I think no one will use that, no? I think no one will use that. So typical tie arrangement. So typical tie arrangement. So with 4 longitudinal bars, with 6 longitudinal bars, with 8 longitudinal bars, again 8. So these are the arrangement of possible tie design. Okay? Typical. Okay? Typical. And number 7, the code states that where longitudinal bars are located around the perimeter of a circle, a complete circular tie is permitted. Okay? The ends of the circular tie must overlap by not less than 6 inches. Okay, 6 inches overlap with the standard hooks that engage a longitudinal column bar. Hook that engage. What do you mean by that? Hook. We have a hook that engage like this. It engages. Okay? So next is safety provision for columns. So we have what? As I mentioned, for the column, okay, the value of reduction factor is 0.9 for safety. And for shear, that is 0.75. Okay? So, for flexure and shear. For flexure, 0.9. For shear, 0.75. The value of 0.65 is specified for tied columns and 0.75 for spiral column. So, just like what I've said, spiral is 0.75 and tied column is 0.65. Okay? A slightly larger phi is specified for spiral column because of their greater toughness. Toughness because of the spiral. So, design formulas. We have what? So, force times E is equal to mu. So, E is the eccentricity. Okay? This is eccentricity. So, you can use that. Eccentricity. If the loading is eccentric, okay, you can also multiply this. So, we already have this formula. Just multiply by pi. Okay? Just multiply by pi. That is the main formula for design of column. Okay, for tied column, you have to use 0.65 here. And the formula will also have 0.8. Take note, for spiral, that is actually 0.85. So 0.85 times pi, which is 0.75. So 0.85 times 0.75. But here, the formula is 0.8 times 0.65. Right, for tied columns. Right? So, it is to be clearly understood that the preceding expressions are to be used only when the moment is quite small or when there is no calculated moment at all. Okay. So, comments on economical column design. So, therefore, small percentage of steel, therefore that is economical. Okay. So, how much? 1 to 4%. So, our target is 4%. So, also spacing of ties. Okay. Sorry. Okay, design of actually loaded column. Let us actually do the example. So, this is our last topic example for the day. So, we are given a design square. Design a square tied column to support an axial dead load 130 and axial live load 180. Initially, assume that 2% longitudinal steel is desired. FC prime 4,000, FY 60,000. So, solution. You have to do the combination of load 1.2 dead load, 1.6 live load. We have the steel ultimate load, okay, or service load. Okay. Selecting column dimension. So we have phi PN. So this is this design. Design strength is equal to phi times 0.8. So what is this? Tied column. So tied column, you use 0.8. So quantity 0.85 FC prime area A minus AST plus FYST. Okay? So therefore, put it there. So design or service load, design strength is equal to 0.65 tie. So pi is 0.65 for tied column times 0.8. Then quantity like this. Therefore, we can find out the value AG. AG is the area of the column. Area of the column, then actually you can take the square root of this. Okay? Take the square root of that. Then that is the dimension of the column. The square root of 108. So you can use what? 14 by 14. That is a good number for the column dimension, which is greater than this one. Okay? So, selecting longitudinal bars. after column dimension was selected, so we have to design the reinforcing bars. So we can find out the value of ST. Okay? This is in the formula, but here, as you can notice, we use 2%. 2%, but still, so initially assume 2% still. So that's why we are able to, because there are two unknowns, one equation, two unknowns. How can you solve? First, assume 2%. So between 1% to 4%, so assumption 2%. Okay? So we can find out the value of steel area, therefore 6 bars. Okay? 6 bars. How many? 6 bars of number 7. So the value is 3.61. So very near. So it is our most economical part. Now, design the ties. How to design the ties? There are 3 ways about the spacing of the ties. Okay, so it could be this one, this one, this one. So 48. So we can make the spacing. Okay, and least dimension is 14. Okay, least dimension, this is what I know about. The least dimension is 14, so that is also the spacing 14. But letter A, letter B, I don't know. Okay, so this is 48 times what? 38. Okay, then 16 times 78. So this is the provision that we took note of a while ago. So 3/8 and then 7/8. I know this is somewhere there. So here, okay, code diameter, okay. This is 3/8, okay. So where is the other one? Anyway, those are the code provision for a tied column. So since that is the spacing, so you have to select the smallest, no? So closer, the spacing is closer to one another, unlike this one. So these are closer. 14 inches is closer you compared to 18 inches. So use this one. Use number 3 ties. So this is the normally used for the type of bars, which is number 7. Okay, so we can use number 3. So the sketch is like this. Okay, the column that we design. So 14 by 14, we have 6 longitudinal bar, we have ties, number 3 at 14 inches spacing. Okay, 14 inches spacing. Okay, so we have concrete cover 2.5, 2.5 on every concrete cover. Okay, so check the code requirements. So let us check the code requirements. So longitudinal bar, clear spacing. So 9/2. So inches minus 7/8. So that is the spacing which is greater than 1 and dB of 7/8. Okay, so this is okay, meaning the gravel will be able to go around and in between the steel bars. Okay, so steel percentage, so greater than 1%. If you can exactly calculate, so we assume to be 2%, but after the computation, actual is 1.8%. Okay, so less than 8%, that's its maximum. Number of bars, 6. So that is okay because rectangular, 4 is the what? Minimum. Minimum tie size, number 3, that is okay. For number 7. Spacing of ties, okay. That is the minimum dimension. Arrangement of ties, okay. So, we are through with the design of column. Any question? So, any question, you have to practice solving. So, these are the practice problem solving. Okay? So, I will just post instruction on the GC. There are no question. Again, this is Dr. AP preaching engineering for nation building.